Our MatOx focuses on development of novel materials-related technologies. We look for early-stage IP that is developed further in joint programs with industry and academia. And in this 3-year project, the customer was a global paint company specializing in coil coatings. The key idea was to use computational modeling to design new coatings with improved properties for the customer. And to succeed in this, we formed a collaboration with Aalto University's Computational Nanoscience Group, COMP, where we had 2 postdocs working full-time over the course of the project. The project was divided into 2 tracks, one concentrating on improving the hardness and formability balance of the coating, and the other one in developing coatings for energy-efficient buildings. In the mechanical properties track, we took a computational method that has originally been developed for biomolecules. And we implemented that method for our industrial polyester system. And to be able to model this complicated system, we used a method called CoAS graining. This approach enabled us to move into more realistic time and length scales compared to atomistic level simulations. The resulting data helped us to understand more about the physics of the coating. The data from the simulations may be presented, for example, as animations, and we were able to see, for example, what happens to the cross-linking agent during the initial stages of curing. The second track concentrated on coatings for energy-efficient building. This work was done by modeling nanoparticles in a polymer matrix. The idea was to tune the absorption and reflectance properties of the paint without compromising its visual appearance. Compared to traditional experimental methods, modeling proved to be a great tool. Instead of merely dispersing nanomaterials in the paint and testing them, we were able to test the effectiveness of countless types of material specification before entering the actual experimental stage. And here are some coated test panels. And these 2 actually have the same absorption profile, but this one is made by using nano additives and this one by using standard carbon-based additives. And as you can see, this one appears visually much darker than this one. In conclusion, computational methods can be a feasible route in application development. The models represented the physical characteristics of the coatings reasonably well and enabled us to take more efficient route for experimental trials. The project did include a risk element, and therefore the role of Teges as a co-founder was critical for a small company like us. At the end, we would like to thank Teges for their support and all the partners involved in the project.